Funicular. This is a chart showing the 4 different types of cable-propelled transit systems. In this chapter video, we will focus on the funicular. These are the location of the different types of mass transportation systems. A funicular can be below the ground, on the ground, or above the ground. This is an example of a funicular on the ground. This is an example above the ground. And this is an example below the ground. These are the possible configurations of a funicular. These are the trains with their travel directions. And these are the tracks that the trains travel on. A funicular is a type of cable-propelled transit consisting of 2 trains that move back and forth along a railway placed on a slope. The 2 trains move simultaneously. As one train goes up the slope, the other goes down the slope. The 2 trains are permanently attached to each other by a cable that is looped over a bull wheel at the upper end of the railway. The weight of the train counterbalances the weight of the other train. In this way, the only energy needed to propel the train is the differential weight of the passengers and the forces needed to overcome friction. A funicular works similarly like an aerial tram that we have shown in a previous chapter video. Instead of 2 cabins, 2 trains go back and forth connected to one cable, moving in the opposite directions. The main difference is that in most funiculars, its 2 trains share the same track in most of its travel. Looking at the photo on the right, the 2 trains of the funicular swings to their right sides on separate tracks at midpoint. It then resumes traveling on a single track until it reaches its destination station. The bypass or passing point is provided so that the trains do not bump into each other. The main purpose of using only one track is to save on costs. This sharing of the track cannot be done in an aerial tram in the sky. Let us look at the history of the funicular. The first funicular was built in a rural area in Stockton, UK. 40 years later, the first urban funicular would be built in Lyon, France. Lyon at that time was already one of the biggest cities in France in terms of population. These are funiculars from 1893 to 1991. These 2 funiculars in Kiev, Ukraine and Istanbul, Turkey are very old funiculars that continues to be renovated up to the present time. The one in Istanbul is the oldest surviving funicular in the world at 138 years old. These are funiculars from 1991 up to 2017. Funiculars before 1991 were slow and low capacity. The Montjuic funicular in Barcelona, installed in 1991, was a big improvement in capacity and speed. Succeeding funiculars would achieve similar or better speeds and better capacities. Many of the funiculars, particularly in Europe, are old, but they are continually being renovated up to the present time. One way to renovate is to upgrade the internals and then maintain its classic looks, as in the case of the Hong Kong funicular. Another way to renovate is to upgrade the internals and then modernize its looks. One of the busiest streets in the most populous city of Istanbul, Turkey is this road. It is narrow and steep, which is very tiring to walk for pedestrians. A tunnel to host the funicular was built under this road surface. Although it is very short, the funicular can be considered to be the second oldest subway in the world. It is next only to the London subway. This funicular serves this busy road today, the equivalent of 175 jeepneys per hour traveling below the road. Another example or renovation is this most famous viewing area in Paris, France. Sac is a tiny hilltop in the center of flat Paris. And one more example of renovation is this funicular in Monte Santo, Italy. Funiculars and cable liners are similar, This table shows their differences and similarities. The following are photos of more funiculars around the world. This is an example of a single-lane shuttle funicular. Only one train goes back and forth. If the length of the route is short, waiting time is also short at only 3 to 5 minutes. This funicular goes through buildings in an old, crowded neighborhood in Lyon, France. This is another example of a funicular going through a building. This is located in Zurich, the largest city in Switzerland. Edmonton, Canada. Johnstown, USA. Pittsburgh, USA. Wellington, New Zealand. Bergen, Norway. Prague, the capital city of the Czech Republic. Graz, Austria. Hong Kong, China. Los Angeles, USA. Ljubljana, the capital of Slovenia. Porto, Portugal. Innsbruck, Austria. Nizer, Portugal. Capri, Italy, and Montserrat, Spain. Budapest, the capital of Hungary, and Baku, the capital of Azerbaijan. Bridgnorth, UK, and Zagreb, the capital of Croatia. Penang, Malaysia, and Lugano, Switzerland. Valparaiso, Chile, and Alexotas, Lithuania. Niagara Falls, Canada, and Great Wall, Badaling, China. Quebec, Canada, and Pau, France. Ronda, Italy, and Mendel, Italy. An open-type funicular in Kaprun, Austria.
3 funicular lines in Vietnam.
And finally, Tagaytay, Philippines. Funiculars can navigate very steep vertical and horizontal curves. Cable liners can do the same, but to a lesser extent.
BRT, LRT, and monorails can travel a maximum slope of only 7 degrees. Funiculars can travel along slopes of up to 48 degrees.
The technique in curving the line of a funicular is by the use of guide pulleys. The guide pulleys can be leaned to the left, vertically, or to the right to create different curved directions. The cable will always be at the center line of the rail tracks when the train is pulled by the cable. Moreover, the cables are always in tension so that it will not slip out of the grooves of the pulley. Funiculars can cover lengths of up to 5 kilometers and navigate through sharp horizontal curves. This photo shows a funicular navigating through moderate vertical curves. Traveling steep alignments can be uncomfortable and scary for some. Engineering methods are applied on the train and train tracks to make the ride as comfortable as possible. To achieve a fixed slope, you can do it in 4 ways. Firstly, by cut and fill operations of the soil or ground. The tracks of this funicular completely sits on the ground. Thus, this is clearly cut and fill operation on the ground. Second, by tunneling. Thirdly, by building a structural railway. Fourthly, a combination of the 3. Once an alignment has been decided upon, appropriate train designs can then be chosen.
For constant steep slopes, there are 2 options. Option A is a piggyback train. Option B is an inclined train. In both cases, the travel of the passenger will always be level.
In a piggyback train, the boarding and deboarding platform is level. In an inclined train, the boarding and deboarding platform is inclined. The seating on the train is inclined. The seats are placed across the inclined slope like in a theater, but the passengers will always be seated in a horizontal position. For moderate slopes with changing slopes, a hinge or gangway is installed. This will allow adjustment to the changes in horizontal and vertical curves. Next, we look at how a funicular tackles steep slopes with changing slope. Here, you can see a steep slope. Farther ahead, the slope changes to flat. To keep the train level, there is a need for this leveling device. This is easy to do for short and small capacity trains. Let us review the capabilities of a funicular compared to all other self-propelled systems. BRT, LRT, and monorail can travel up to its maximum slope of 7 degrees. As previously shown, a small funicular with a low-capacity 1 cabin can travel much steeper slopes. For higher capacity funiculars in very steep slopes, the technology required is more complex. In 2017, Doppelmayr installed a 5-cabin funicular that can climb a slope of 48 degrees. This is the funicular train that can navigate such a steep slope. Without a leveling device, passengers would be positioned during travel almost like astronauts in a rocket during takeoff. Another is during the initial lift of a roller coaster ride. In this funicular, passengers inside the train will be seated in a perfectly horizontal position throughout the trip. This is made possible by this rotating cabin that can automatically rotate to make the seating position always horizontal. This funicular operates not only during winter, but all year round. The end cabin looks weird and out of place. This cabin is actually for carrying cargo. This is the view of the train when it parks at the station for deboarding and boarding. It is positioned flat in an equally flat platform. This is a 2007 funicular in Innsbruck, Austria, of similar design to the 2017 funicular in Switzerland. Both cabins and trains become level at the passenger platform area. As they travel along a steep slope, the trains incline, but the cabin floors remain level. These are the specs of both funiculars. This is the lower station. It enters a tunnel that is good only for one track, which is all a funicular needs. The train exits on the other side of the mountain towards the upper station.
An underground funicular usually needs only one track. It is medium capacity that is much cheaper to build. It is most efficient in medium capacity corridors. In contrast, a subway needs 2 tracks and is very expensive to build. However, it has a very high capacity. Both the funicular and subway makes economic sense under certain conditions and applications.
The following are 2 notable and recent funicular installations. This funicular was installed in the capital city of Luxembourg in 2017. Photos are provided here to let viewers know some of the developments and features of newer funiculars. This funicular line has 2 sets of funiculars side by side. This is why you can see 2 bypass lanes. This is one of the stations of the Luxembourg funicular. Shown on the right is the schematic diagram of the 2 lines side by side. This is the interior of the passenger train. It is fitted with hand grips just like most other modes of mass transportation to maximize capacity. This cabin has a glass roof for additional views. Most CPTs are eager to show its mechanisms to fascinate the passengers. This funicular is no exception. This is a view from the train being pulled towards the station. This is a view from the bull wheel pulling the train towards the station. These are different views of the stations. This is a funicular on an elevated rail, just like cable liners, LRTs, and monorails. It will serve medium capacity corridors where it can be more efficient and economically viable. The air conditioning units can be seen on top of the train. Unlike Manila's LRTs, there are no unsightly wires above the train as a source of power for the air conditioning and electrical needs. The power source is integrated and hidden along the rails. The pro in this installation is that there is no visual pollution. The con is that the cost of the installation is higher. Funicular with multiple stations. Most funiculars only have 2 train sets and 2 stations. In a few cases, funiculars can have multiple stations for as long as they are symmetrically located. An actual example is this funicular in Haifa, Israel. To preserve heritage structures and prevent disturbance from pedestrian or vehicle traffic, this funicular is underground. Because it is underground, it is called a funicular subway. It has 6 stations using only 1 train track and 2 train sets as shown in this route map. This is a typical station platform. These are the photos of the 6 station entrances and their corresponding passenger platforms. This is a simulation of a 6-station funicular similar to the actual 6-station funicular in Haifa, Israel. The red and blue circles represent the 2 opposing funicular trains. When the circles simultaneously stop, it represents the deboarding and boarding of passengers. Then, the trains simultaneously continue to travel towards the next station. The following are urban applications of funiculars in selected cities. This is the transportation map of Lyon, the 2nd largest city in France. It is a multimodal transport system consisting of subway, trams, and funiculars. Lyon is the host of the first urban funicular in the world in 1862. It was converted into a road tunnel in 1968.
It has been replaced by 2 newer funicular lines in different parts of the city.
These are photos of its 2 newer funicular lines. This is the transportation map of Naples. It is a multimodal transport system consisting of subway lines, railways, and funiculars. This city has 4 funicular lines. Naples is the 3rd largest city in Italy. These are photos of its 4 funicular lines. This is the transportation map of Barcelona, the 2nd largest city in Spain. It is a multimodal transport system consisting of subway, trams, ART, and funiculars. The city has 3 funicular lines and 2 ART lines. These are the photos of its 3 funicular lines. This is the transportation map of Istanbul, the largest city in Turkey. It is a multimodal transport system consisting of a subway, trams, ART, funiculars, and BRT. The city has 4 funicular lines. It also has 2 ART lines. These are the photos of the 3 funicular lines. The latest line is under construction and will be completed in 2022.